Good morning, everybody. This is Dr. Christopher Tassone, founder of Sama Learning here. Today I want to talk to you guys a little bit about the periodic table, this wealth of information that tells us so many things about chemistry. And the very first thing most of us learn is how the periodic table is organized according to the electronic structure of atoms. And what that means is there are trends in things like the size, our ability to pull an electron off an atom, our ability to put an extra electron onto an atom. And really what this means is this table can tell us a lot about how atoms interact with each other, what bonds are likely to form, and really what molecules are available for us to make as chemists. And so the first trend we learn about is the trend in size as we move across a period. So we can start with the example of comparing lithium. So you can see here, these are the Slater atomic orbitals for lithium. And we can compare lithium to neon. And when we do that, we can see really clearly neon is much smaller than lithium. And this is because even though we had to place more electrons and build more orbitals to make neon, the charge that is experienced from the nucleus pulling on those electrons is greater. And so they move in closer and closer to the nucleus. And the result is you end up with a smaller atom, even though you have more electrons in it. The second trend that we learn about when we look at the periodic table is the trend as we move down a group. So here, if we wanted to look at neon again, go ahead and pull that up. And then we're going to move down the group and go ahead and pull xenon up. Whoa! We can see that xenon is so big that I am inside of it. So let's shrink that down. And I'm just going to make xenon 10% of its scale here, just for comparison. So we can clearly see that xenon is much, much larger than neon in this case. And the reason for that is we have added 44 additional electrons, and all of those electrons had to get their own combination of quantum numbers, and all of those electrons had to be placed in an orbital with progressively larger and larger ends. And each electron that was added screened some of the nuclear charge from xenon, and so they got more and more diffuse as time went on. And so what we end up with is the second trend on the periodic table, that atoms get larger as we move down a group. And ultimately, this leads to the general trend in the periodic table, which is that atoms get smaller as we move from the bottom left corner all the way up to the top right corner. So let's just go ahead and look at that. Whoa, here's cesium again, blowing up, filling up our whole screen. I'm going to go ahead and shrink cesium down to 1% of its size. And then let's compare that with helium. So one of the largest and one of the smallest. And we can clearly see that helium is significantly smaller than cesium. So that's all I wanted to share with you guys is the first trend in size. A lot of the other trends are related to this trend, but really all of these are reflective of the fact that the periodic table is organized according to the electronic structure of the atoms. Thank you so much. Look forward to talking to you in future videos.